Today's lesson is on the sine function. So typically I'd be giving you this handout and we would be filling it out together as a class. Obviously we can't do that, and so we're going to do the next best thing. So what's going to happen as I work through this worksheet with you, or this lesson with you, is that I'll be explaining what to do and letting you take some time and do it yourself. So what I'm really recommending is when I say and do this now, you pause the video and try and do it before you hit play again, before I throw in the answers. So to start, what we would do is complete the chart below. For the changing values of the angle, use 2 decimal places. So your calculator needs to be in degree mode. I've already went through how to change that, but if you don't see a little D or a DEG in the top, please make sure that that's in degree mode before you start. So, depending on your calculator, some of you will be hitting sine and then the number, some of you will be hitting the number and then sine. What we're going to be doing is we're going to be working through this chart. So sine of 0, you can pull your calculator out right now, is going to be 0. And sine of 15 is going to be 0.26. This might be a little tough for me to fill that in here. Now, what I'm going to ask you to do right now is pause the video and finish off the rest of this chart all the way over here to 720. And then when you hit play, I will have everything filled in so you can double check your work. At this point, we have the entire chart filled out, and what you probably noticed as you were typing all of these out and filling them in is that you saw the repeating pattern that we've been talking about in previous lessons. So we're seeing the repeating numbers, we're seeing the periodic motion, it's going up, it's going back down, it's going back up. At this point in time, we're going to be graphing the function. So I just have a really long axis drawn right here. Again, I'm going to get you to pause the video soon and try and plot these numbers so you can get a graph. And then when you hit play, mine will be filled in. Just so that you know, I'm not going to suggest that you plot each of these numbers specifically. I'm okay with you plotting 0, and again, maybe 90, 180, 270, 360, and so on. So pause that video actually before you start. This will be 1, and then down here will be a -1. So pause that video. When you hit play, I will have the graph drawn in for you. So you can see my really rough graph of the sine law plotted here. The main thing that I really need you to get from this is that there are some key points. So our first point is going to be 0, 0. That's really important that we recognize that the sine graph starts at 0, 0, or goes through the origin. The next point that we're going to be interested in is this point right here. So this is at 91. Now this is going to be a peak, the highest it's ever going to get. Our next key point is going to be 180, 0, and then I'm sure you guessed it, we're going to have a trough down here, and it's going to be important, so a 270, -1, and then finally our 360, 0. So what this represents here, these 5 key points represent one cycle or one period of the sine graph. When I look at the next couple of questions, is y equals sine x periodic? Yes, it absolutely is. We see this up, reach a peak, down, hit a trough, up, reach the exact same peak pattern repeating itself. What is the period? So I already highlighted in yellow the period. I don't have the numbers drawn in here, but this was 270 and this was 360. So we can see here that the period is equal to 360 degrees. That's how long it takes for one cycle to occur. What are the x-intercepts? So I've got an x-intercept. Where does this graph cross the x-axis? So the first one is going to be at 0. And then I've got another one here at 180, and then another one here at 360. And you could see I'm just adding 180 every single time. So here's the next one at 540. Here's the next one at 720, and etc. So just keep adding those 180s. Where are the peaks? So our first peak is right here, and it's at 91, 90 comma 1. Our second one is right here, and it's at 450 comma 1. So you'll notice that between the 90 and the 450 is a full period, a full 360 degrees. Now, you can get more peaks, or all of the peaks, by adding 360. Where are the troughs? So the troughs, I have two drawn in my graph. My first one is at 270 negative 1. My next one is at 630 negative 1. Now again, between 270 and 630, you're going to see that one cycle, or the 360 degrees. And again, you could just keep adding 360 to figure out more troughs. I've also answered the last part of both of these questions. What is the maximum value and what is the minimum value? I answered that by plugging it in for the y values here. So our maximum for the peaks is 1 and our minimum for the troughs is negative 1. Moving on to the back of this worksheet, so the axis of the curve is the horizontal line, so that's the line going this way, halfway between the maximum and the minimum. So when I'm looking at this, I have a formula, y is equal to max plus min divided by 2. Now this makes sense, it's just the average. So our maximum is 1, our minimum is negative 1, divided by 2, so 0 divided by 2, so 0. And that makes sense that our equation of the axis of the curve was at 0. We know that that x-axis is the middle point. Moving on, the amplitude. So again, those of you that took physics, you've definitely seen this before. The amplitude of a periodic function is the distance from the axis of the curve to either the peak or the trough. So I'm just going to quickly draw our sine graph in here again. So it went up and down and back up. And so my axis of the curve was this line right in the middle there, and my amplitude is this distance. So from the axis of the curve to the trough, and likewise it could be from the axis to the peak. So the amplitude is always a positive value, so you're never going to have an amplitude of negative 1. It's just kind of, you would say the amplitude is 1, and it could be, going up or going down. So we just always say positive. Now, the formula for this, we do have one. We could use the formula maximum minus minimum divided by 2. Or if you have a graph, you could just take a look and see what that amplitude is. Ours was 1. And I could see it just by looking at my graph. It went from 0 to 1 or 0 to negative 1. But if I wanted to do the work, I would do my maximum, which was 1, minus my minimum, which was a negative 1 over 2. 1 minus negative 1 is 2, and 2 over 2 is equal to 1. So here's my official sketch 1 cycle of sine. So hit 90, 180, 270, 360. Label the axes of the curve. So that's the blue line. And I'm just going to say AOC. And then I'm going to label my amplitude right there. And again, you could label it down here if you wanted. It means the exact same thing. Last question. Sarah is sitting in an inner tube in a wave pool. The depth of the water below her in terms of time can be represented by the graph shown. Discuss and interpret the graph. So right away, the first thing that I'm going to notice is that this is definitely periodic, okay? I'm seeing the exact same pattern. It's hitting the exact same peaks and the exact same troughs. The next thing that I'm going to see is that the middle of this graph, or my axis of the curve, is going to be right here at 2. This means that this is her middle point. Now, if you're thinking about this, a wave pool, if there were no waves, that would mean that the depth of the pool was 2 meters. pool is 2 meters deep. Now, the next thing that I'm seeing is this amplitude. So from here up, it's not easy to see, it's not labeled, but from here down, I can see that the lowest she ever gets is 1.6 meters. So I know right away that the amplitude is equal to 0.4 meters. That's the difference from the 2 to the 1.6. So this means that the waves are moving her 0.4 meters down, back to her center point, 0.4 meters up. The last thing that we're going to be talking about here is our cycle or our period. So I could see that it does one full rotation every 3 seconds. So every 3 seconds, Sarah hits a high point, a low point, and gets back to her resting spot. So she has a big wave every 3 seconds. Just like we graphed the sine function, we can also graph the cosine function. Now, I'm not going to go through all of the exact same steps again. You're more than welcome to create a table of values so you could see the graph form as you go. I think what's more important is that you recognize the differences between the sine function and the cosine function. So we know the sine function starts at our equation of our axes, or at 0, and heads up first and hits its peak. The cosine function actually starts at a peak, so it starts at 1 and heads down to its equation of its axes. It then continues down and hits its trough, going back up to hit its equation of the axes, and then back up to a peak, and so on. So what you really can see is that this is the exact same as a sine function. I'll just draw it in this way too so you can see it goes both ways. It's the exact same as the sine function, but it's been shifted over. So typically this is where the sine function would start, because we know that it would start at the middle and head up. So cosine function and sine function are basically the same. They have a lot of the exact same properties. So the period for both is still 360 degrees. The amplitude for both is still 1. The maximum is 1 and the minimum is -1. So none of this is changing. Really, the only change that is made is that it starts at a peak. And finally, I guess I'll talk about your domain, still XER, and the range is YER, such that Y is between -1 and 1. And just because I haven't said it yet, and I think you should add this to your note, you can add in somewhere that this is the cosine function. And if you wanted to write it out, it would be y is equal to cos of x.